Hello guys, welcome to next lesson of CCNA 200 Rehab to 301. Today our discussion is about the STP. Kindly subscribe to IT Expert channel if you have not did. Let's start from the concept of STP, why we require STP. I will design here for you and explaining why we require the STP. Assume that we have some switch here, switch A and switch B. These two switches connected together. So each of these switch have a backup A from backup B. This backup is connected through here, and this backup is connected through here, and this connect here. So for that, we require the redundancy for releasing or the or reliability of our network. So if we create like this the switch, so the switch will create the loop for because the switch will broadcast the package each time. So from preventing the loop from the network, we will use the STP. We have type of STP. So some of them will block one cable. Assume this. The package is when coming here, it will block at this because it's not in using. When in case of the connection from main will be used, lost it, then the packet will go through here. That's the scenario and the concept of STP. Let's go deeper about explanation of STP. If we don't apply a STP and our redundancy switch network, how it will, what are the problem it will be faced. So the first problem it will face is the broadcast storm. What is the meaning of broadcast storm? Assume that the switch A, switch B is the main switch. Let me write here so it will be good for you. Switch A, switch A, switch B, switch B. So switch B. So in case a switch will receive a packet will be coming in a switch, like from outside the packets will come it, and the destination of packet is the the port, example this port. The destination of the switch is switch B. So when a switch A receive a package, it will broadcast the package. Assume it will broadcast the package from this port, it will broadcast to this port and not except to the source port. It will broadcast to all the port that is connected. It will broadcast the frame from this port as well. So when the switch receive it, when the switch B receive this packet from this port, it will broadcast. It will also broadcast from this port and this port. When this receive it, it's checking that this packet is not from depending from this switch. It will again broadcast. That's why it will creating loop. It will create a lot of loop. So in this case, we will use the STP. STP will block one port. So when a switch broadcast the frame, it will check there is not another port, so it will not creating loop in here. So another problem will be created is multiple frame is the transmission. So how multiple frame is transmission? Assume that it send one frame to the switch B. Again, it will looping from here, it broadcasts, again it's receiving the same package. So multiple unique frame will be received. And MAC address instability. How MAC address instability is in here. So when a switch receive a packet, when a switch receiving a package, it will add the MAC address. Example, this switch A received one packet from here. The destination MAC address is the switch B. Switch B will receive it the uh, the frame. So in a MAC address, he will write the source and destination MAC address. Source from where and destination is where is. So when it's broadcast again, there is also a MAC address in this switch. So when again it receive it from another side of port, example this port, now this port is the source. It sended this package. Again it will be created another MAC address. So loop will be create instability of MAC address as well. Let me show you the hierarchical network that in hierarchical network you will require the STP 100%. Assume this access layer distribution access layer distribution layer core layer access core distribution access. So in here is multiple switches using. Okay, about the STP algorithms, let me explain for you the STP algorithm. STP is using STP spanning tree protocol. It is 802.11d. It's IEEE standard for communication. This STP will be use it when the package will be sent from a switch A to switch B. It will block one redundancy link. So when it's blocked, it will not create a loop. So how it will recognize when the main link got down or failed, how it will recognize then the blocked link should become up. STP by default send the PBDU every 2 seconds. Every 2 seconds it will multicast the frame, so it will show the state. This port is up. It's asking this port is up. Yes, it's up. So it's continue. When this port is up, yes, it's up. This port is up. Like this, it will multicast the frame every 2 seconds. So in case when something has happened, the main link got down, so it will become up. It's from blocking state, it will go to forwarding state. Okay, STP convergence. STP convergence example. Let me come in scenario. So in here, how they will choose that these ports should be blocked and these ports should be in forwarding state. How they will converge the STP. Okay, let me explain to you. First of all, STP will be selected when a root bridge. Root bridge will be selected with the least priority BID, bridge ID. So in a bridge ID by default in each switch bridge ID is 70. BID by default in switch is 32,768. By default this in all switch. You can change the priority of the switch. Okay, for B with the lowest BID, the switch which have the lowest BID will be selected as a root bridge. So when the root bridge will be selected, if the BID will be same, then they will choose the lowest MAC address. The lowest MAC address of the switch will be selected as a root bridge. When they choose it the root bridge, so each port of the root bridge will be in forwarding state. Let me show you. Each port, assume that it's selected as a root bridge. Each port will be as a forwarding state. It have two ports, so both of it will be selected as a forwarding state. Okay, the switch which is an root bridge, like this switch and this switch, the port of this switch will be, assume this switch will be have two two connection. The lowest cost of the switch, the lowest cost of the link, which have the lowest cost to reach the bridge ID will be selected as a root port. Assume this link have the lowest cost. How you will calculate the lowest cost, I will show you. Or this this port have the lowest cost to reach the switch A, and these costs have the low this link have the low this port have the lowest cost to reach the switch B. It's not possible. This assume that if this port have the lowest cost to reach the destiny the bridge ID, then this port will be as a root port. Please remember this. The port of an an and root bridge switch which have the lowest cost to reach the bridge ID will be selected as a root port. And the port which have the lowest cost to reach the bridge ID, then that link will be selected as a designated port. So other link will be in a blocking state, or just root port designated port will be in transmission state, and the other port will be in a blocking state. So here is the full explanation. I will upload it this material in description. You can click on the link and you can read the books. Okay, let me explain the cost of the link. The link which have the 10 MB per second speed, the cost will be 100, and when the link have the speed of 100 MB per second, the cost will be 19. The cost of 1 GB speed is 4. 10 GB speed will be 2. Remember, you should remember this. Okay, type of STP. STP type first coming from STP definition. As I told you, the STP is defined 802.1.1d. I had already explained it to you how it will work, how it will look doing loop free in a topology. And sometimes STP is calling for CSTP, Common Spanning Tree Protocol. Common Spanning Tree Protocol. It is IEEE standard. So PVST, one thing more about the STP, is STP. One STP stands for entire bridge of a network. So one STP will be implemented to all of these network. So PVST is a Cisco priority. So it's enhanced of a STP. So just it's doing the same thing like STP, but one thing is different. That's it's instance for each VLAN configured on the network. Like assume that in this switch that we have two VLAN, VLAN A, VLAN B. In this switch also we have two VLAN, VLAN A, VLAN B. This PVST will implement to VLAN A, VLAN example VLAN B, to connect it to VLAN B. Like this STP will implement to each VLAN configuration. So rapid STP. Rapid STP is also an IEEE standard 800.1W. So it's just doing the fast convergence. It's same like STP. It's the just different is this RSTP is just doing fast convergence. It's like STP is instance the entire bridge. So the third one is rapid PVST plus. It's the Cisco priority. It's enhanced of RSTP. It's using per VLAN, is configured instead of per VLAN, but faster than PVST. MSTP, multiple spanning tree protocol. is IEEE standard. So it's MSTP multiple, it just multiple maps, multiple VLANs into same instance, multiple in same instance spanning tree protocol. This MST is an Cisco and also IEEE standard. IEEE standard is 802.1s and also is the Cisco period. Here is the different and also the speed of convergence, all of them. How PVST operation doing? So the first one thing, the all Cisco catalyst switch is by default configured the PVST plus. PVST plus is working like this. Previously I explained the STP. PVST STP has blocked one port. Example, it will block one port and it will not use it that port. But PVST is not PVST is different. PVST each VLAN, example this VLAN A, VLAN B, VLAN A, VLAN B, VLAN A, VLAN B, VLAN A, VLAN B. So it will create STP to half of this VLAN, and one STP it will create to the next half of VLAN. Example, it will select this port, this switch as a bridge ID for VLAN A, and this switch will be selected as a root bridge for VLAN B. In this case, for the switch A, example, it will block this link. For the VLAN, for another VLAN, it will block this port for a transmission. So in this case, you will using all of your port state in PVST. We have blocking state, listening, learning, forwarding, disable. So in a blocking state, when a link will be in a blocking state, it just can receive and process the PBDU. It's been the bridge ID. It received the information about the other ports. So it's receiving except the disabled port, disabled state, all blocking, listening, learning, all of them will be received the PDU. Can forward the frame. In blocking, listening state or learning state, they cannot forward the frame except the frame is the forwarding step. Can forward data frame switch from another interface. Just forwarding, just doing in forwarding state, not other state. Can learn the MAC address. Blocking state cannot learn, listening cannot learn. In a learning state, forwarding state, they can learn the MAC address. Rapid PVST operation. So as I have explained it to you, the RSTP is the same like STP, but RSTP is the convergence of RSTP is faster than STP. So the rapid PVST is just for each VLAN it will doing the fasting convergence. So example, the performance convergence of RSTP from the 15 seconds it became to less than 10 seconds. It's doing the faster convergence. Okay, the definition, as I told you, the standard of IEEE 802.1W. Another selecting and convergence is same, but one thing is different. In RSTP, we don't have the blocking state. Instead of blocking state, we have discard state. This is the state different between STP and RSTP. So in STP we have blocking, listening, learning, forwarding, disable. But when RSTP we have discard. Instead of blocking we have discard. Instead of listening we have discard. Just we have learning, forwarding, and discarding. These three states. In one forwarding state they can forward the frame. Ports are also different in RSTP, we have root port, designated port, alternative port, backup port, disabled port. In STP, we don't have such alternative port like backup port. This port we don't have. This is a scenario of the RSTP. Assume this switch become the root bridge. This port will become the designated port, root port, designated port, designated port. So this is the alternative port and root port. Okay, about the let's start the configuration of STP. So this is the default setting to by default the switch which have the enable STP will be enabled on VLAN 1. The PVST and MSTP rapid PVST are disabled by default. The switch priority, as I told you, 72,768, and also the configure the priority of spanning tree by default is the number 128. The cost of the speed and also the hello timer. Hello time is 2 seconds, forwarding delay time is 15 seconds, maximum gain time is 20 seconds, and transmission count is 6 PBTU. For better configuration of STP or RPVST, you need to configure two things for load balance. One is bridge ID and the second is the port cost. As I explained it, how they selected the bridge ID, how they will, what is using of port cost. Let me configure in packet tracer how you can change the bridge ID, how you can change the port cost. Okay, I'm using packet tracer to configure the STP. Let me configure the STP using packet tracer. Okay, I have connected the port. So let's start. Our plan to configuration is changing BID, changing cost of link, automatically set the bridge ID, no, root bridge, and backup of or designated road bridge or road bridge. So as I told you, by default the STP is configured in switch. You can see the one port is disabled, and it means it's in a blocking state. So let's check the configuration which switch is now the root bridge state. Enable show spanning tree summary. Show spanning tree summary. You can check that this switch is selected as a root bridge. By default is selected as a root bridge, and let me check this one. Show spanning tree summary. This is non-root bridge switch. You can see that forwarding state is 2. It have 2 forwarding states. Let's check the third one switch. Show spanning tree summary. It have the forwarding state 1. One port is disabled. So this switch is selected as a root bridge, and these two switches non-root bridge switch. And this port is in blocking state. So let's change this scenario. Our plan will be we will select this switch as a root bridge. We will change the BID. One important note you should know about the BID: when you have planned to to increment the BID or decrease the BID, you should multiplex or plus these 4096 from the real BID. Example, I want to decrease the BID of this switch. So the default BID, as I told it, used 32,768. So our plan is this should be the root bridge, and this switch should be, let me write it, root bridge, and the backup root bridge. And this switch should have one blocking port state. So let's start the configuration. So I'm just calculating to select the bridge ID. So the real and the default BID is 32,768 minus 4096. I will assign this number to the backup one. It should be the root, it should be the secondary. Primary, it should be the secondary. And I will minus again from the 28,672 minus 1496. I will assign this BID to the root bridge. Okay, let's start the configuration. We are coming to CLI. Enable conf terminal spanning tree VLAN 1. The root, this root will be primary. So spanning tree VLAN 1 primary. Now we'll select this number. How much was the number? BID 24,576. Yes, I have changed it this one to bridge ID. Do WR exit. You can see this now. This switch will become, this port will become the blocking state. I don't want this be the block state. I want this one should be the block state. So I'm changing the BID of this as well. So coming to conf terminal spanning tree VLAN 1 root primary. It should be the secondary. Yes, it should be the secondary. Spanning tree VLAN 1 secondary. Priority should be how much? This priority should be selected as a 28,672. To WR. Yes, this switch is changing the state, and now this port is in blocking state. So with this command you can change the bridge ID. One thing more I want to explain now that this is the blocking state. I don't want this port be in a blocking state. I want to be this port in blocking state. The second one should be in blocking state. This fast Ethernet 01 should be in blocking state. So I need to change its cost. Okay, one configuration of the port is this, so we can configure the port as a port fast and PVDU guard. Port fast, what is doing the port fast? Port path is the increase the convergences. It's direct from blocking state is going to forwarding state, not learning, not listening, and it's just going to the forwarding state. So we need to configure that's first we need to configure the port fast. Then we need to use the PBTU card. PBTU card is why we require to use the PBTU card, because we will disable to it receive from PBTU. It's directly going to the forwarding state. Okay, let's configure the port fast. How you can configure the PBTU card on port fast. Configure now interface fast 02 switch port modish access switch port sorry spanning tree port fast. Listen, when I enter the spanning tree port fast, it's getting warning because the port fast and PBTU will be configured in access mode, and that the port should not be connecting as a trunk, or it should not connect to another bridge or a switch ID. If it is connected, then it will create a loop. You can configure it to let me add one laptop here. I will configure this for laptop. Interface 03 switch port modish access spanning tree port pass. You recognize again we got the warning. So let's check why we got the warning. So enable conf terminal interface version 083 switch port modish access switch port sorry spanning tree port fast. This again we are getting the warning. Let's check the status of spanning tree. Show spanning tree interface fast 03 port fast. Port fast VLAN 1 is already enabled, so you can disable the spanning tree at this port. Command configure terminal interface fast 083 no spanning tree PBTU code port fast. Let's check now. Show spanning tree interface 083 port fast. Now it's disabled. So it was enabled. That's why we got the error. Okay. We have configured the PVST STP. So as I told you, now we are going to configure the rapid PVST. As I told you, by default the PVST is configured in the switch. How you can change the PVST to rapid PVST? Okay, let's change the PVST to rapid PVST. In configuration mode, come on to spanning tree mode. Now it's PVST to rapid PVST, just this one. It will change to rapid PVST, WR or copy running config to startup config. Yes, it's just changing this from PVST to rapid PVST. So some show command that verifying the STP configuration. I will explaining to you. Show spanning tree summary. It will explain it to you which VLAN is using and how many port is in forwarding mode, like VLAN 1, how much port is in forwarding mode, what is enabled in here, so which one is branch ID. So it will explain all the things from to here. If you want to know the specific interface or a specific VLAN STP, show spanning tree, we can give VLAN 1. It will explain it to you. VLAN 1, this is the road port, this one is fast Ethernet 02, this is the road port, and the second is designated port. And also it will explain it to you the priority priority and the cost of the Ethernet. So the next show spanning tree, which one details show spanning tree active. It will listing the active PVST for you. Show a spanning tree, show a spanning tree the interface, specific interface. You can show a spanning tree details, all information about the STP. Thank you so much. This was our today lesson. Kindly subscribe the YouTube channel, comment your idea, comment your question in the below of video. Thank you so much.